Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Sodium acetylide, HCCNA, is a strong nucleophile. When it reacts with a dihaloalkane or a molecule bearing to different leaving groups, it will selectively attack the more reactive, better leaving group, site via SN2. Moving on to the next step. Identify the reagents. HCCNA is sodium acetylide, a Carbanian nucleophile. The substrate is Cl-CH2-CH2-CH2I, which has both a chloro group and an iodo group. Moving on to the next step. Determine selectivity. In SN2 reactions, iodide, I, is a much better leaving group than chloride, Cl, because C-I bond is weaker and iodide is more stable as a leaving group. Therefore, the acetylide nucleophile attacks the carbon-bearing iodine, the primary carbon at the end of the chain. And for the final step, write the reaction. HCC attacks the CH2I end, displacing I to give HCC CH2 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 Cl. The chloride end remains intact because it is a poorer leaving group and is not attacked under these conditions. Evaluate options. A. HCC CH2 CH2 CH2I. This would require displacement of Cl, which is less reactive, not the major product. B. CH2 is equal to CH, CH2I. This is allyl iodide, which is unrelated to this reaction mechanism. C. HCC CH2 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 Cl. This results from displacement of I, better leaving group, by the acetylide, correct major product. D. CH2 is equal to CH, CH2 Cl, allyl chloride, unrelated to this reaction. Therefore, the correct answer is C. Therefore, the correct answer is option C.